Good day, everyone. Welcome to today's physics class. In today's physics class, we are going to be discussing this topic on the board. If today is your first time of coming across this page, please do well to follow, hit the like button, and also share this post to greater people on this platform. Yeah, we want to learn equilibrium of forces. So I did paperwork on this as well as solving some examples. But now let me explain this topic in the video way so that somebody can understand it fully. Now, when we look at the word equilibrium, to a layman, it means something different, okay? So the way a layman views it may not be the way we view it in physics. So to a layman, equilibrium means when two things are equal. That means there is a balance. All right. Now, when we relate this now to physics, it also means something like that, okay? But now let us look at objects that we see around us. So every object we see around us, we continue to remain at rest. We remain at rest or continue to move uniformly along a straight line unless it is acted upon by force. Now, when several forces act on a body and the body remains at rest or continues to move uniformly, so it means the forces are in equilibrium. So the body does not accelerate. So it is the unbalanced force that brings about what? Acceleration. So equilibrium of forces occurs when a body remains at rest under the action of several forces. If it remains at rest or continues to move with uniform velocity along a straight line, so it means equilibrium of forces has been attained. Now, let us look at what we are trying to say. Equilibrium of forces can only occur if a body remains at rest like this. This is a body, remains at rest. And there is a force coming this way. Let's say there is a force this way, and there is a force another direction. Now, along this line, this is what F1, this is F2. This body can only move if one of the forces is greater than the other. Now, if this F1 is equal to this, it means this body here will remain at rest. It will not move. Now, in other case, if a body continues to move along a straight line without changing the velocity, so it means the body is in a dynamic equilibrium. So it is the velocity, change in velocity that produces acceleration. Now, equilibrium is attained when there is no acceleration, when the object does not accelerate. At this point now, F1 is equal to what? F2. So that the algebraic sum, the vector sum of the forces acting along each direction here, so it now gives us the algebraic sum of the forces now will be equal to what? 0 at this point. So it means F1 minus F2 equal to 0. Here is a state of what? Static equilibrium. So equilibrium is of two forms. Mainly, we have two main types of equilibrium. We have the static equilibrium and the dynamic equilibrium. So if a body remains at rest under the action of several forces, so that body is said to be in a static equilibrium. Like this body here, a body remains at rest. Let's say, for example, we have a force this way, 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 acting on this body. And this object remains at rest. So it means that in every direction, the summation of the forces remains what? 0. In that case, there is no unbalanced force. It is the unbalanced force that produces the acceleration we are talking about. So, for example, in this case, the sum of all the forces, the vector sum, which is the resultant of all the forces acting along x, this x-axis, is equal to 0. And that of y, the vector sum of all the forces acting along y-axis must be equal to 0. So in this case, we say that this body is in a state of static equilibrium. Now, dynamic equilibrium If a body or an object continues to move with uniform velocity along a straight line, or continues to rotate with a constant speed, so in that case, we say that that body is in a state of dynamic equilibrium. Why do we say when it moves with a constant velocity? So when we say that when a body continues to move with constant velocity, so that same body is in dynamic equilibrium. Somebody may be confused since motion has to do with movement. Now let me tell you, not all movement that involves acceleration. There are some motion or there are some movement where acceleration becomes zero. So in that case, motion is not recorded. Now look at this now. We are told that acceleration is equal to what? Change in velocity all over what? The time taken. Now, if the velocity is remaining constant here, in that case, it means that what? V is equal to what? U. V is equal to U. That is the final velocity equal to the initial velocity. In that case, so if we say that what? Okay, V, it becomes V minus what? V all over T. So this becomes what? 0 all over what? T. And in that case, acceleration becomes 0. So acceleration here becomes 0. That is why when an object is moving with uniform velocity along a straight line, so that object is said to be in what? Dynamic equilibrium. Though it is a force that is what acting on that object that makes it to have a constant velocity. So for acceleration to be produced, the velocity has to change. That is about that. Now, what are the conditions for this equilibrium? Like we all said, under the action of several forces, for that body to remain in equilibrium, there are two main ways we are going to consider that. We have the translational equilibrium. That is where we are having a line along a straight line, where we have the object here moving along a straight line, okay? So this is called translational equilibrium. Now, the algebraic sum of all the forces here acting in any direction on this object must be equal to 0. What is that algebraic sum? The vector sum. So the vector sum, that is f of s, must be equal to 0. And the vector sum along the y-axis must also be equal to 0. So this is the first condition of what? Equilibrium. And this one is called translational equilibrium. Now, there is this one we call the turning equilibrium or rotational equilibrium. And that deals with what? The couple or the moment we are talking about. So moment, in my next topic, in my next video, I am going to explain the basics of moment. Now, in that case, if we want to consider moment for us to attain equilibrium, so it means that what? The sum of all the upward forces, the vector sum, remember force is a vector, so you must put the word vector. So the vector sum of all the forces along one direction, or the upward forces, it must be equal to the vector sum of the downward forces. So in that case, the algebraic sum of all the forces acting on that body must be equal to 0. The next one is the summation of the moments. The sum of all the moments. The sum of all the moments. The moment is a vector quantity, okay, must be equal to 0. What does that mean? It means the clockwise moment must be equal to the sum of the anti-clockwise. So there are two main types of moments. We have the clockwise, the clockwise and the anti-clockwise. So for us to attain equilibrium, in this case, the clockwise moment must be equal to the sum of the anti-clockwise moment. Now, equilibrium, there are different life applications that you can see equilibrium. Now, examples of equilibrium in real life. Look at a beam balanced on a pivot. That is an example of equilibrium. Also look at a meter rule balanced on two supports. When you balance it on two supports, that becomes a state of equilibrium. Now you that is standing right there, standing still on the ground, you are at the state of equilibrium. You are in a state of equilibrium because you are standing, you are not moving. So it means you are in a state of equilibrium. And also a signboard that is hung somewhere, a ladder that is leaning against a vertical wall. That is an example of static equilibrium because the ladder is leaning against the wall. Unless a force acts on it that will push the ladder away from the wall. So that is an example of what? Equilibrium state. Then we also look at a book that is resting on the table. A book resting on the table is an example of static equilibrium. Now, a car moving with what? A constant speed along a straight line. It's an example of dynamic equilibrium. Are you see that now? So there are different life applications where you will see a state of equilibrium. So in my next video, I am going to explain more on the conditions of equilibrium. So we take moments as our case study where we have to consider the action of parallel coplanar forces. We have parallel coplanar forces, then non-parallel coplanar forces. When coplanar forces are acting on objects, so what is the condition for the equilibrium? Now, in equilibrium, when three forces are acting on an object, we use triangle law of forces to represent the forces together. So that is what we want to learn now on this equilibrium. So in my next video, I will be bringing examples, questions and answers on this equilibrium, as well as what? Introducing us to moment of a force. If you find this class very interesting, please help us to share this post and do well to like and comment. Bye.